Hi, my name is Ryan. I'm the developer and founder of VapeJet. This is the VapeJet 3.0 product demonstration video. I want to thank you in advance for taking the time to watch this video and learn about some more of the features of the VapeJet system. And I want to let you know if you have any questions at the end of this video, please don't hesitate to reach out to myself or somebody on the sales team, and we'd be happy to assist you and answer any further questions you have. So without any further ado, let's get into the main components of the VapeJet system. So everything starts with our reservoir systems, and you're going to see this reservoir a few times throughout this presentation. It holds 1 liter of oil and is entirely stainless steel. There's also a dip tube inside and some other components that we're going to discuss later. One thing I'd like to point out is the entire fluid path is made from stainless steel, PTFE, borosilicate, and ceramic. So it's a product safe fluid path all the way through. After it leaves this reservoir, your fluid is going to go into the pump housing here. Now this is heated as well. So you'll notice that there is a heat wrap around the reservoir here. There's also an active heater that keeps this chamber here at a precise temperature. Finally, at the very bottom of it is a needle heater. This is another independent heat zone in the system that you can set up through the software so that you can set the temperature of the oil as it leaves the system right before it goes into the needle. So you can give it a little bit more heat here so that your product isn't dwelling under a long time of high heat. It only passes through this portion of the system very briefly. So heating this up a little bit hotter can actually help get the oil into the cartridges without keeping the oil warm throughout the entire dispense process. Another thing you'll notice about our machines is they all have this holder for this 100 milliliter overflow container that's used for calibrating the machine as well as hovering the needle over when the machine isn't in operation to catch any drips. The entire enclosure of the VapeJet system is positively pressured. There's an intake fan, and it's also temperature controlled. There's no active heater inside the enclosure, but we have an intake fan which pulls in filtered air, which can push out the warm air that accumulates inside from the rest of the heaters. So you're able to control the temperature inside this chamber. Finally, all of our systems feature this machine vision camera system, which you're going to see in action later, but it allows you to fill these foam trays directly without needing to transfer to a jig. And you'll notice this foam tray is very bowed. The cartridges don't need to be in there very precisely for this camera system to pick them up. In addition to the machine vision camera, we also have this enclosure camera, which gives a live view inside the machine and lets you see what's going on. Finally, this entire assembly can move up and down inside the enclosure, and that's important when you're switching between half grams, full grams, or all-in-one style cartridges. You don't have to manually reconfigure the machine or use standoffs underneath. You just put the new product onto the tray, hit one button, and it will reconfigure itself to fill that device. And finally, the universal tray system, as enabled by that machine vision camera, it doesn't matter what the tray is, we're able to fill it within a few parameters, which we'll discuss later. All right. So let's do a deep dive on the fluid path and pump system. So as we were talking about earlier, this is the product reservoir. It's a stainless steel reservoir with tri-clamps on top and bottom. There's a pressure relief valve at the top for safety reasons. A gas quick connect fitting to attach the nitrogen to, which we use to pressurize the system. The fluid output is a standard compression fitting. Inside the tri-clamps we provide Viton gaskets. This dip tube here allows us to pull the oil from the very bottom of this reservoir when it's inside the system, so that you only have about 1 milliliter of residual oil inside this canister when you go to change it out. And finally, the heater wrap, which is put around each one of our systems. and that is so that you can keep the oil inside this canister at a specific temperature. And you see here it's connected to our drop tank system, which is just a preheater. This allows you to preheat the canister before it goes in the system to allow you to perform quick swaps. Moving on to the pump, we integrate a Hamilton PSD4, which is a pharmaceutical grade syringe pump. The valving system is ceramic on ceramic, so there are no one-way valves, there's no pressure actuation in here. There's an actual motor sitting right here which turns a ceramic piston inside to select the correct port. Both the syringe pump and the valve are controlled by stepper motors and encoders. The encoders is important so that we can measure the physical position that the valve or the syringe is in, not just what the software tells the stepper motor to go to. And the reason that's important is for our viscosity compensation. So on the accuracy and repeatability of these pumps, each one is tested to NIST standards. You can backtrack the calibration that was done, which machine was used to calibrate it. These are all done by a third party prior to integration. But you can see the precision and accuracy of these pumps. We're typically doing a 30% stroke. Is down at 0.007 or 0.009%. Extremely accurate and repeatable pumps. Now, for viscosity compensation, we do some magic inside the software, which will monitor the stepper and encoder positions and slow down the pump if it encounters any difficult to pump fluid. In other words, the pump will always finish dispensing the requested amount, but it'll slow down if the fluid is too viscous or if it encounters a pocket that's hard to pump. And finally, one of the really cool things about our pump is the ability to change the speed between the charging and dispensing stroke. So in other words, you can independently set the speed as the syringe pulls back or as it pushes forward. And that really comes in handy because our supply side is pressurized with nitrogen. So certain fluids that don't like to be exposed to vacuum or they start bubbling a lot inside the cartridges are able to be filled with our machine because you can just slow down the charging speed and wait for the fluid to be pushed into the syringe rather than allowing the syringe to pull a vacuum up inside. Now, if you're doing something like distillate with terpenes, doesn't matter, just go fast. Okay. Now we're going to get into the actual machine GUI, and the first thing we're going to talk about are configuration profiles. So in the VapeJet interface, you can load and save different profiles. Each one of these profiles contains all the information the machine needs to fill those type of cartridges with a specific oil. Okay? So things like heater set points, the type of cartridges, how many cartridges are in a tray, along with a lot of other parameters are included in this configuration. Once you're done setting it up, you save this and you can come back to it later. So I'm going to make sure that my ceramic 1 profile is loaded. Okay. And I'm going to focus the machine. Now, if you recall from earlier, this top platform here looks a little different because this is a demo machine and we have the panel pulled off so you can see what's going on inside. But this top platform is going to move down so that the needle can reach the cartridges. So I'm going to hit focus camera, proceed, and you'll notice that starts moving down. Now if I move the cartridges here, you'll also notice my camera's nice and aligned there. Okay. So that's configuration profiles. Now let's jump into the operation wizards. Now all the wizards in this machine are set up with the SOPs built in. So we're going to go to Operation, Load. And what you're going to notice is every time you do an operation with the VapeJet system, you're going to be presented with the SOP. Furthermore, any buttons that the operator needs to click are included inside the wizard here. So it tells you what you need, what you're going to do, and then brings the button right to you. So next, it walks you through what you need to do to install this reservoir here inside the system. It tells you that you need to heat it up. It tells you that you need to pressurize it. It walks you through how to pressurize it. Then you need to prime the lines and pump. Again, it's all software based. There's no physical adjustments needed here. And all the buttons that you need are brought right to the operator. Once this is done, you hit next and finish. And we're going to go straight to dispense. So the Dispense Wizard, now that the canister is loaded, is going to walk the operator through loading the machine. So placing an empty tray of cartridges on the tray. Lining it up real quick by showing it where the first and the last cartridges are. Ensuring that the product is heated up. And then moving on to the Dispense Wizard. Now, I'm going to hit dispense, and we're going to talk about what the machine is doing, and we're going to pause and stop it in a few places. So I'm going to hit dispense, and I'm going to switch camera views for a moment. See, it scans the tray, moves to position 1, and it's inserting the needle and performing the fill cycle now. Now, I'm going to hit pause, and we're going to walk through all the different functions the system is taking. So step 1, it moved to where the cartridge should be. Now, as you'll recall, these foam trays are not perfectly aligned. So what we have to do is we calculate where the cartridge should be, and then we measure where it actually is. So when I hit continue, you're going to see the system pull this cartridge directly into the center of its view. Okay. Now that the cartridge is perfectly in the center, we're going to measure the center post location in relation to this outer wall. So I'm going to hit continue and hit pause again, and it went too fast. We're going to try to pause it again at the right spot. So let me try to catch it. This all happens very quickly. This is a perfect example. So what you see here is the center post in relation to that outer wall. And what this yellow line is indicating to the system where it's going to attempt to place the needle. So for cartridges that are very far, that have bent center posts, if you tried to insert the needle at the same place every time, if the center post happens to be bent that direction, it's going to scrape the inside of the center post. However, our system, we measure, detect, and average this angle, and this tells the system that we're going to insert the needle at the widest point of the cartridge. So I'm going to hit continue, and I'm going to switch camera views here. And you'll notice that the needle went down inside of the cartridge. Okay? When I hit continue, the pump is going to move forward at the same time the needle is going to retract from the system. See that? So it slowly pulled out of the cartridge as it pushed the fluid in. Those movements are timed together so that the very tip of the needle never hits the actual fluid level. It's always hovering just above the fluid level as you're filling the cartridge. Once it's done with that dispense process, the pump is actually going to back off ever so slightly and suck the tiny little drip at the end of the needle back up inside before we switch the valve to the input to recharge the pump. Okay. I'm going to hit continue. And watch the system do that a few times in a row, just to get a feel for how it's working. You can also see that this map right here is updating in real time. Okay. Now I'm going to stop the system here so that we can move on and I can demonstrate other functions. One thing that I'd like to point out is now that I've introduced an air into the system, it's hard to see from this camera, but the internal lights of the VapeJet system have turned red. The LED indicators indicate to the operator what status the machine is in. Green means it's ready to be loaded, red means there's an air, and blue means it's running. So I'm going to hit stop here. Once you're done filling cartridges for the day, you're going to need to unload this canister. You want to reclaim all the oil that was left inside these lines, and the way that we do that is we use the nitrogen pressure to push out of that dip tube, push all this oil out of the line into the catch container that we discussed earlier. Once that's done, you're going to load the system with a cleaning solution and walk through this wizard that takes you through a clean-in-place procedure. Once you get to the cleaning cycle, you're going to hit clean and walk away for 5 minutes. The system is going to do a self-clean. And this is all, again, all of these wizards are step-by-step instructions, and all the buttons that you need to press are brought directly to you. Okay. Once you're done cleaning out the system, you also run a drying cycle, where we use the nitrogen to blow out the system. Okay. All right. So that's the operation wizard. Let's go ahead and talk about the data reporting functions of VapeJet real quick. Okay. So clicking back over to our interface, every time the system is run, we get a report. So if you click on this report, let me find one that I let run for a while. So here's the one that we just ran together. So every time there's a dispense operation, you get a report, which includes the total runtime, the tray size, the configuration that was used, the last time that configuration was modified, the table speed, charging speeds, dispensing speeds, all the information that pertains to that operation. You can further drill down on an individual cartridge location and get a picture of that cartridge before it was filled and after it was filled if you have that feature enabled. How long each cartridge took. This one took a while. We must have paused it. Yep. Okay. The temperatures that it was filled at, the locations, and the difference between the center post and outer circle. Okay. You can also download all this information in a zip file, and inside that zip file is a JSON file which you can import into Excel along with all the pictures that you can export if you're trying to figure out a problem with a fill cycle. So that's all there is to reporting. The calibration wizards. So to do all of this filling, there's a few things that need to be set up on the system. We need to teach the system how to look at a cartridge. We need to teach it how far the needle is away from the camera. And we need to teach the pump how to handle the fluid that we're dispensing. So we're actually going to go through all those really quickly. First thing we're going to do is show the system how to look at a cartridge. So Calibration Camera. First thing you're going to do is set the focus. This is where you move that top platform up and down and set the height of the device you're filling. Okay. Once you have the system in focus, you're going to tell it how big of a circle to look for. So we don't want to detect that right there. We want to detect the entire center post. So you can just drag these over and show the system how big of a cartridge to actually look for. The rest of this is just setting up filters to prevent mist detections. And then you do the same thing for the outer circle. You tell it how big of a circle to look for. Okay. Next, you're going to need to calibrate the needle. This is all wizard based as well. So next, show it where the position of the needle should be in the up position. Align the camera. And again, it's going to take you step by step through all of the things you need to do to set up the system and give you instructions along the way, as well as the controls you need to perform that step. Okay. Finally, let's talk about pump calibration. So this is how you set the system up to dispense the desired amount of fluid. So we're going to click through this one all the way, and I'm going to explain these steps. So first thing, hit next. We're going to set an initial position of how much oil to dispense. So let's say you're going for 1 gram. I'm just going to drag this around 1 gram. You don't need to get it precise yet. This is just a rough measurement. Okay. Next. Now you're going to set the speeds of the pump. Earlier in this presentation, I was talking about the fact that you can set independent speeds on the pump. This is the screen that you do to do it. So, just to for an example, I'm going to make it very slow on the charging side and very fast on the dispensing side. So watch our pump right here when I hit cycle. Very slow to charge, very quick to dispense. In all reality, it's going to be more around here. Quick to charge, a little slower to dispense. You can set these speeds up to accommodate the specific oil along with the specific temperatures that the oil is kept at. Okay. Next. Now here is where we're going to calibrate the system. You're going to tell it exactly how much you want to dispense. So let's say you wanted to dispense 1.07 grams. You type that in, number 1. Now, you're going to hit cycle pump, and it is going to dispense once into this catch container, which we have teared out from a previous step. You're going to type in exactly how much it dispensed. So let's say it dispensed 1.18 grams. Type that into the second box and hit next, and the system has internally recalibrated itself so that it will always dispense the exact amount you typed in the desired box. And you can verify that now by hitting cycle pump and measuring it again. Okay. That's all for the demonstration on the system. If you'd like to go into a deeper dive on any of the various aspects of the system, again, please contact myself or the sales team. And I will finally follow all this up with all this technology and all these systems are only important if you have good support. Support is key to automation equipment. We pride ourselves on having some of the best post-sale support in the industry. We really try hard to work with our customers and make sure that you are happy with the machine and that you have the throughput and uptime that you need for your business. We can overnight parts. We do on-site repairs if needed. And one of the benefits of this being a software-driven system is we can remotely access these machines to pull the log files and actually identify the problem and then either ship you replacement parts or a lot of times just fix it remotely from our end. Because the entire system is software-driven, we're able to fix most things remotely without an on-site visit or a lot of times without any replacement parts. All systems receive 12 months of that coverage. We cover shipping, we cover parts, we cover labor, we cover everything. We really want to emphasize that this is a partnership between us and your company, and we're here to make sure that you are happy and that your machine is working as advertised. I won't take up any more of your time. Thank you again for listening to all this, and hope to work with you soon.